Namaste everyone. Welcome to fifth lecture of application of derivatives. This is Rajesh. In this lecture we are going to discuss maxima and minima. Now maxima means maximum value and minima means minimum value. So here we are going to understand how we can find maximum and minimum value of a function using derivative. Let f be a function defined on an interval I, then f is said to have a maximum value in I if there exists point C in I such that f of C is greater than or equal to f of x for all x belonging to I. Now here we are understanding first what we mean by the maximum value. So for a given interval means for a given range of x, the value of fx will be minimum. Here we are discussing maximum. The value of fx will be maximum at a point C if at point C fx attains the maximum value, that is f of c is the highest value, that is f of c is greater than or equal to f of x. Here the number f of c is called the maximum value of function in I, and the point C is called the point of maximum value of function in I. Now see this graph. In this graph we have drawn function for f of x. Now as we move from left to right, we see that the value of function is increasing, and when we reach at C, there we find that the value of function is maximum, and the maximum value of function is f of c, and this maximum value is obtained at point C. Second, f is said to have a minimum value in interval if there exists a point C in interval such that f of c is less than or equal to f of x for all x belonging to I. I hope you understand now this minimum value. For maximum value we have seen that we get the maximum value of function from graph, it is easy to identify. Similarly, when the value of function is minimum, okay, at point C for all values of x, then we say that f of c is the minimum value, and it is minimum at point C. So the point C is called point of minimum and f of c is called the minimum value. Now see here in this graph, at point C we are getting the minimum value, which is this value, right? At all other point, if you see the value of function, it is more than f of c. Third, f is said to have extreme value in I if there exists a point C in I such that f of c is either a maximum value or a minimum value of the function in I. Now in the previous 2 points we have seen maximum value, we have seen minimum value. Now that maximum value and the minimum value, they are called extreme values. So extreme values could be either maximum or minimum. So when I say that I am getting extreme value at point C, that means I am getting either a maximum value at point C or a minimum value at point C. The number f of c is called extreme value of the function in I, and the point C is called the extreme point. A point A in the interior of domain of function is called local maxima if there exists delta greater than 0 such that f of x is less than f of a for all x belonging to a minus delta and a plus delta. Here f of a is called the local maximum value of the function fx at the point x is equal to a. A point A in the interior of domain of f. So let us see with this graph. Now here in this graph you can see that this graph is like first it is decreasing, then after point A, beyond point A it is increasing, then again at point B it is decreasing, then at point C it is increasing, then at point D it is decreasing. Okay, so we are seeing that at point A and point C we are getting minimum value, and at point B and at point D we are getting the maximum value. Now these values, these minimum or maximum values, they are called local minimum or local maximum values. So point A and point C, they are point of local minima, and point B and point D, they are local maxima, point of local maxima. Now if you see the definition, what it is saying, that if f of x is less than f of a for all x belonging to a minus delta and a plus delta. Now a minus delta, a plus delta, so for point A, the value towards its left is a minus delta and towards its right it is a plus delta. So for left value and right value, okay, if I calculate, they are going to be greater than f of a. They are going to be greater than f of a. So if f of a is like here for maxima, if I say, then for point B, suppose at point B, the value at left and value at right, they are less than f of b. So I will say that f of b is local maxima, okay, because it's a left value and right value, they are less than the value at b. So here f of x, if it is less than f of a, okay, for value of x which is belong to a minus delta and a plus delta, that is left value and right value, if the value of f of x is less than f of a, so then this f of a is maximum, local maximum, and I will say that it is local maximum at point x is equals to a. I hope you got the idea, okay, what is local maximum. So if there are not a single maximum or minimum value, there are many maximum and minimum. So we define local maxima, local minima for a given range, and when we say that it is local maxima, when the value towards left of the point and right of the point is less than the value at point, as here in case of B, okay, the value towards left and towards right is less than what value I am getting at point B. So the point B is called point of local maxima, and the maximum value is whatever value we get here, f of B. Similarly, if I come to at point D, for point D also towards its left and towards its right I am getting lesser value, okay, delta, where delta is a very small value. So for a very small change in the position of D towards left and towards right, we are getting the value of function as less than f of D. So I will say that D is point of local maxima. So here B as well as D, they are the point of local maxima, and in the same way point A and point C, they are the point of local minima. A point A in the interior of the domain of f is called the local minima if there exists a delta which is greater than 0 such that f of x is greater than or equal to f of a for all x belonging to a minus delta comma a plus delta. Here f of a is called the local minimum value of function at the point x is equals to a. The point at which a function changes its nature from decreasing to increasing or a vice versa are called a turning point. Now in the previous diagram, if we see the previous diagram here, we are seeing that the function is turning at point A, then it is turning at point B, then at point C and at point D. So how we come to know they are turning? So function is changing its nature from decreasing to increasing. So here first it is decreasing, then it is changing its nature and it is becoming increasing. So point A is called a turning point. Similarly point B is a turning point, C is a turning point and D is a turning point. Through the graph we can even find maximum minimum value of a function at a point which is not even differentiable. Means if the function is not differentiable at any point, then also we can find its maximum and minimum value if graph is given, okay. So from graph it is easy to identify what is the maximum value, what is the minimum value. Every monotonic function assumes its maximum minimum value at the endpoints. Now you know monotonic function means it is either increasing function or it is decreasing function. So when function is monotonic function, then it assumes its maximum or minimum value at the endpoint. So if it is increasing function, then towards right it will attain its maximum value and towards left it will attain its minimum value. Every continuous function on a closed interval has a maximum and a minimum value. Now if a closed interval is given, closed interval means they have given like from 2 to 4 and both 2 and 4 are including, and between that they have given one function. So that function must have a maximum and a minimum value. So at least one maximum and one minimum we can identify. Okay, you can draw the graph, and from graph you can easily understand the minimum and maximum value. Let the function defined on an open interval I, and suppose C is a point on I. If f is a local maximum or a local minimum at x is equals to C, then either f dash C is 0 or f is not differentiable at C. F dash C is what? F dash C is differentiation of the function at point C. Now here we are now introducing derivative, how we use derivative to get maximum or minimum value, or to get the point where we get maximum or minimum value. Now if the function has a local maxima or local minima at any particular point, then at that point derivation will be 0, that is f dash C will be 0. Critical point, a point C in the domain of function at which either f dash C is 0 or f is not differentiable is called the critical point of the function. Now as in the above point we have seen that if at point C it is maximum or minimum, then we get derivative at that point 0. So this point C at which we get derivation as 0, or this point C where the function is not differentiable, that point is called critical point, and at the critical point we could find either a maximum value or a minimum value. So here we have introduced how to utilize derivation in case of finding maximum or minimum value. So one thing we understood, that if the function is maximum or minimum at a particular point, then at that point either its derivation will be equal to 0 or the derivation is not, we cannot find derivation, that is it is not a differentiable function at that particular point. Now here there are two ways by which we can find maximum or minimum value, or we can find the point at which the function is maximum or minimum. First is, one method is first derivative test. First derivative test means here we are going to differentiate the function once, and we have one more method called second derivative test. Here we are going to differentiate the function twice. So let us first examine how using the first derivative test we arrive at a maximum or minimum value of a function. So let f be a function defined on an open interval I, and f is a continuous at a critical point C in I. Then if f dash x changes sign from positive to negative as x increases through C, then C is a point of local maxima. So what it indicates, that if derivative, now f dash x, so far we have understood that the derivative of a function at a particular point is nothing but it is slope of tangent at that particular point. So here we have drawn two tangents. Now tangent, value of tangent, okay, if it is from left to right, okay, if the tangent is like that, then it is having value greater than 0. So for increasing function the value of f dash x is greater than 0, and for decreasing function the value of f dash x is less than 0. So you can see that as we are moving from point C, means we are crossing point C from left to right, the derivation is changing its sign from greater than to less than 0. Okay, first it was greater than 0, that was the function is increasing, then it is less than 0. So if the value of a function, the value of derivative at point C is 0, and it changes its sign as it move through C from positive to negative, then it is said to be having a local maxima. So if f dash changes the sign from positive to negative, here you can see that f dash x, it is greater than 0 and here it is less than 0, it is changing sign from positive to negative, therefore at point C we have local maxima. From graph it is easy to understand how we are getting local maxima. Now if f dash x changes the sign from negative to positive as x increases through C, then C is the point of local minima. So from negative to positive, so you see here f dash x is less than 0, the slope is negative, then as it reach at point C and cross it, the derivative change its sign from negative to positive, and hence we say that k, the function is minimum at point C, or we obtain local minima at point C. Third, if f dash x does not change sign as x increases through C, then C is neither a point of local maxima nor a point of local minima. Such a point is called a point of inflection. So we have seen two cases. In one case, okay, f dash x, it is changing sign from positive to negative, and at the point we get local maxima. There is one more case in which at a point the function, the derivative f dash x is changing its sign from negative to positive, and there we are getting local minima. Now there could be a chance that f dash x, as it passes through point C, it does not change its sign. Then that point, okay, that point is called point of inflection, and at that point we have neither maxima nor minima. So you can see this graph here. If I draw a tangent towards left, then we get an increasing function, and if I draw a tangent towards right, there also I get an increasing function. So f dash x is greater than 0 and it changes, okay, as it moves from point C onwards, then also f dash x is greater than 0. So at this point, at this center point, the function is neither maximum nor minimum. From graph also you can understand that it is not attaining any maximum or minimum value. So this is point of inflection. Similarly here in this case, you can see the point of inflection. Towards left, the derivative is having less than 0 sign, means it is less than 0, and towards right also f dash x is less than 0. So therefore f dash x is not changing its sign, therefore your function is neither maximum nor minimum at this central point, and we say that this point is point of inflection. So this is by first derivative test. So when you are doing first derivative test, what you have to do, you have to find the point at which your first derivative is 0. Then you have to find the value towards left and towards right. Okay, if they have different sign, like towards left we are getting positive sign and towards right we are getting negative sign, so that means f dash x is changing from positive to negative, and hence f of c is the point of maximum. Okay, f of c has the maximum value. So this is how we use the first derivative test and find local maxima. Similarly we find local minima. For local minima again we find f dash x equal to 0, we find the point C where derivation is 0, and then we find the value of the function towards left and towards right. We find the value of, we find the value of derivation, okay, derivative of the function towards left and right. If they are changing sign from say negative to positive, then that point is called point of minima. Okay, that point is called point of minima. If it is not changing its sign at all, then that point is called point of inflection. So this is how you are going to use first derivative test and find the maximum and minimum value and find the point at which you are getting maximum and minimum. So here I discussed how we get the point of maximum and minimum. Now to find maximum value of the function, it is simple, that whatever point I got, whatever value of x I got, that value I will put in function, I will put in fx, and that fx will give me the maximum value or minimum value. Now let us discuss the second derivative test. Okay, this is a little easy as compared to first derivative test. Here what we are doing, here we differentiate function two times. So let fx be a function defined on and c which belongs to interval I. So fx is a function defined on the interval I, and we have one point c which is belongs to I. So f be twice differentiable at c, then and your function should be twice differentiable. Okay, then x equal to c is the point of local maxima if f dash c is 0 and f double dash c is less than 0. Okay, so here what we are doing, we are differentiating function two times. When we differentiate first time, we equate that to 0 and we get the value c. So we got f dash c 0. Now at this point c, we find double derivative. If the value of double derivative is less than 0, then I will say that k x equal to c is the point of local maxima. That is, at x equal to c, I will get the maximum value of the function. Okay, local maximum, you understand what is local maximum. So there could be a chance that you have more maximum value. So for a given interval I will get a maximum value. So that is local maximum. And the same way, x is equals to c will be a point of local minimum if first derivative is 0 but second derivative is greater than 0. And the test fail if your first derivative is 0 as well as second derivative is also 0 at point C. So in case the test fail here, what we do? We utilize the first derivative test to find the maximum and minimum value. So if the test fail, then we go back to the first derivative test and find whether C is a point of local maxima, local minima, or a point of inflection. If a function f(x) is continuous on a closed interval ab, then it attains the maximum value, which is called the absolute maximum value or a global maximum value at the critical point or at the end point of the interval ab. So for a closed interval, I can find absolute maximum or absolute minimum. Absolute maximum or absolute minimum, we have seen that we have too many maximum point that we call local maxima, too many minimum point that is called local minima. So in all those maximum and minimum point, there will be one point which has the highest value and one point which has the lowest value. So that is called your absolute maxima and absolute minima. So in a closed interval, we will check the value of function at critical points. Critical points means where derivative is 0, and also we will check the value of function at endpoints, that is at a and b. And after finding all the values, we decide which is the maximum value, which is the least value. So that will give me absolute maximum and absolute minimum, and we will find the point also where we are getting absolute maximum or absolute minimum. Let the function be a continuous function on a closed interval I, ab, then f has the absolute maximum value and f attain at least once in I. Also f has absolute minimum value and attain at least once in I. So what they are saying that when we have a closed interval, then at least one maximum and one minimum value I will get in the interval. Now working rule, how we are going to find this absolute maximum and absolute minimum value. So our first step is find all the critical point of the function in a given interval. So critical point you know how to find, you differentiate and equate it to 0. Second step is at all these points and at the end point of the interval, calculate values of function. Okay, so in first step what we have done, we have find the critical point, and in second step we are finding value of function at the critical point. Now in third step we will identify the maximum and minimum value of the function out of the values calculated in step 2. The maximum value will be absolute maximum value of function and the minimum value will be absolute minimum value of the function. So in step number 2 we have find out the value of function at all critical point. Also we have find out the value of function at end points. Then I will examine which value is maximum, so that will be absolute maximum, and which value is minimum, so that value will be absolute minimum value. So this is how we will find absolute maximum or absolute minimum value. So in this lecture what we have discussed what we mean by maximum value of a function or a minimum value of a function. We have discussed how we can use derivation to find the maximum value or minimum value of function and the point at which we get the maximum and minimum value. So here we discussed two type of interval, one is open interval, one is closed interval. In case of open interval, we will find only the local maximum or local minimum, and in case of closed interval, we can find absolute maximum or absolute minimum value. Now here we have two methods of finding maximum or minimum values, that is local maximum or local minimum values. One is first derivative test and other is second derivative test. In first derivative test we are differentiating function once, we are equating it to 0, we are finding critical value. Then we are checking the value of derivation towards left and towards right of the critical value. If it is changing its sign from positive to negative, then that point will be the point of maximum, and if it is changing sign from positive to negative, negative to positive, then it will be a point of minimum. And if f dash x it is not changing its sign from left to right, then it is point of inflection, that is neither maximum nor minimum. And in second derivative test, what we are doing, we are differentiating function to time. We are equating the first derivative with 0, we find value c at which my first derivative is 0. We put that value in the second derivative. If the second derivative answer is less than 0, then the point c is the point of maximum, okay, and f of c will give me the maximum value. And if we are getting f dash c 0 but f double dash c greater than 0, then that indicates the point of minimum value and we get minimum value. Now if second derivative test we are not able to apply when f dash c and f double dash c both are 0, then we go to first derivative test and find the maximum or minimum value. Absolute maximum and minimum value, they are possible in case of closed interval. So in case of closed interval, what we do, we find the value of function at critical point as well as end point, and then we decide which value is maximum, which value is minimum. Right? So the concept we have seen in this particular lecture. Now in the next lecture, we will solve few problems, okay, for maxima and minima using all types, okay, so that we understand this concept very well. Thank you.